Welcome to YQ Academy Core Java Interview Questions and Answers. 1. Difference between abstract class and interface. The abstract class. An abstract class is a class that cannot be instantiated. It serves as a blueprint for derived classes. It can contain both abstract and non-abstract methods. Abstract methods are declared without an implementation and must be implemented by the derived classes. It can have instance variables, constructors, and defined methods with or without an implementation. It can also provide common functionality and default behavior to its derived classes. A class can extend only one abstract class. An abstract class can have constructors that are called when an instance of a derived class is created. JIT interface. An interface is a collection of abstract methods and constants. It defines a contract that a class must adhere to by implementing the methods defined in the interface. All methods in an interface are implicitly abstract and cannot have implementations. It cannot have instance variables, constructors, or defined methods with implementations. It can only contain constant static final variables. A class can implement multiple interface. Interface are used to achieve abstraction and provide a common interface that can be implemented by multiple unrelated classes. Interface are often used to define the behavior that a class should have without specifying how it should be implemented. Starting from Java 8, interface can have default and static methods with implementations, allowing them to provide additional behavior to implementing classes. 2. What is JIT Compiler? JIT stands for just-in-time, and the JIT compiler is a key component of the Java Virtual Machine JVM that plays a crucial role in optimizing the performance of Java programs at runtime. When a Java program is executed, it is first compiled into platform-independent bytecode. The JVM then interprets this bytecode line by line and executes it. This interpretation process allows for platform independence but can result in slower execution compared to native machine code. To improve the performance of Java programs, the JIT compiler comes into play. It dynamically analyzes the bytecode during runtime and identifies portions of code, known as hotspots, that are frequently executed. The JIT compiler selectively compiles the identified hotspots into native machine code specific to the underlying hardware and operating system. This native code is optimized for the target platform and executed directly by the CPU, providing significant performance improvements over interpreted bytecode. 3. What is bytecode in Java? Bytecode in Java refers to the intermediate representation of Java source code that is generated by the Java compiler. It is a low-level, platform-independent binary code that is designed to be executed by the Java Virtual Machine JVM. When you write Java code, it is first compiled by the Java compiler JavaC. The compiler analyzes the source code and translates it into bytecode instructions. 4. Difference between this and super in Java. 1. Usage and purpose. This is used to invoke a constructor within the same class. It is typically used for constructor chaining, where one constructor calls another constructor of the same class. Super is used to invoke a constructor from the superclass. It is used to initialize the superclass part of an object and is typically used in the constructor of a subclass. 2. Placement. This is used within a constructor and must be the first statement in the constructor body if used. It cannot be used outside the constructor context. Super can be used within a constructor or an instance method. If used in a constructor, it must also be the first statement in the constructor body. 3. Parameters. This passes parameters to another constructor within the same class. Super passes parameters to a constructor in the superclass. 4. Implicit vs. explicit. This is implicitly used by the compiler when there is a need to invoke another constructor within the same class. Super is explicitly used by the programmer to invoke a constructor in the superclass. 5. Constructor chain. This allows constructor chaining within the same class, meaning one constructor can call another constructor within the same class to avoid code duplication and reuse. Super allows constructor chaining between a subclass and its superclass. When a subclass constructor is invoked, it implicitly or explicitly calls the superclass constructor using super. 5. What is a class? In object-oriented programming, a class is a blueprint or a template that defines the structure and behavior of objects. It is a fundamental concept in Java and other programming languages that support object-oriented principles. A class serves as a blueprint for creating objects. It defines the properties, attributes, and behaviors methods that objects of that class will possess. 6. What is an object? In Java and object-oriented programming, an object is an instance of a class. It represents a specific occurrence or realization of a class blueprint. Objects have state attributes/properties and behavior methods defined by the class from which they are created. 7. What is method in Java? In Java, a method is a block of code that performs a specific task or action. It is a fundamental building block of a class and is used to define the behavior and operations that objects of that class can perform. Methods are also referred to as functions in other programming languages. 8. What is encapsulation? Encapsulation is a fundamental principle of object-oriented programming that focuses on bundling data and methods together within a class and controlling their access from outside the class. It is a mechanism for hiding internal implementation details and providing a well-defined interface to interact with the object.